Finally, I'd like to talk about my top takeaways from working on the ECLSS system for all of these years. I think one of the biggest ones is a rigorous test program. I think we learned that with how we had to scale back our initial plan and how that impacted us, and how we learned things on orbit that maybe if we had tested more on the ground, we would have uncovered on the ground. So test, test, test. I know I'm not the only one that ever says that. The next key takeaway would be to test in your actual environment as close as possible. And this is easy for us now because we have the space station. That's the perfect environment to test the ECLSS system. So we need to use it and use it while we have it. Our goal for future missions is to make the improvements we need to make to the ECLSS system and validate them on the space station for at least 2 years, 2 or 3 years before they're ready to take, on a long duration mission where we don't have those links back to Earth that we have now. And so, but in general, you want to test things in the actual environment as close as possible. We learned that with our flight experiments, and we learned that with some of our on-orbit lessons learned that we didn't see on the ground. Another lesson and what we need to consider going forward is the right balance between dissimilar redundancy in our systems and commonality in our systems. We want a healthy mix of both. I think one of the things that has helped us on the space station is that the Russian system is different from the U.S. system as far as life support. And so when we've had a problem come up on the U.S. side, we know we have the Russian to back us up, and vice versa. When they've had issues, we have our U.S. systems. As we go forward, the struggle is going to be, we have obviously weight limitations and size limitations on this vehicle that we're going to be taking to Mars or deep space. And so you maybe can't afford to have a large number of redundant systems, but you need to have enough so that you do have that backup capability. Another thing to consider, things always take longer than you initially planned. I think we tend to be super optimistic at NASA and plan our schedules success-oriented. The development of the life support systems, even though we had spent years working on them in the development stage, when we actually got turned on to, okay, produce this flight hardware, it took a lot longer than we had anticipated, and we ran into more problems along the way, and budget cuts and things that just caused delays. So we need to plan for that as we go forward, particularly if we're trying to hit a mission target. Let's make sure we back up and do our design work early enough that we can allow for a healthy amount of time to go through that flight design and certification process.